Hi, everyone. If I give you a function rule, f of x equals da da da, and it's a one-to-one function, how can you find a rule for f inverse of x? We'll start by using a conceptual approach, and then we'll show a mechanical approach later on, the one you're used to from your Algebra 2 class. Now, for the conceptual approach, understand that f inverse has to undo the process applied by f. I have a question for you. I'm going to take you way back. When you dress, you put on your socks, and then you put on your shoes. Think Mr. Rogers. Now, when you take off your shoes and your socks, what do you do first? Do you rip off your sock? No. You take off your shoes, then you take off your socks. Think Mr. Rogers. I'm not kidding. So what's the point I'm making here? To determine f inverse, we need to invert or undo the steps, taking off your socks, taking off your shoes, but in reverse order. Because even though you put on your socks first, you have to take off your socks last. All right. And then also, if necessary, impose restrictions to make sure the domain of one is the range of the other for f and f inverse. We'll talk about that with temperatures later on. All right. So let f of x equal the fraction, the cube root of x plus 5 all over 7 on the reals. Find f inverse of x. Okay, so we start with the input x. What does f do to x? Tell me the three things in order that you do to x and then the resulting outputs. First, you do what? First, you take the cube root of x. So you take the cube root of the input. And then what do you do to the result? So we now have the cube root of x. What do you now do with the result? You add 5. You add 5 to the result. And then what do you do to this numerator? You divide it by 7. So you can think of the function as applying a three-step process. It takes in the first input x, applies the cube root, takes the result, adds 5, takes the result, divides by 7. Now, what is f inverse going to do? F inverse is going to undo these things. So what undoes taking the cube root of something? Taking the cube of something. What undoes adding 5? Subtracting 5. What undoes dividing by 7? Multiplying by 7. But remember the shoes and socks example. These steps have to be done in reverse order. So it's kind of like here, you're taking off your shoes first when you multiply by 7. So what does f inverse do to its input? You first multiply by 7. Then you take the result, subtract 5. Then you take the result and cube. So what do? We start with x. We multiply by 7. Take the result, subtract 5. Take the result, cube it. And that's our rule for f inverse of x, right here. We take x, multiply by 7, take the result, subtract 5, take the result, cube it. All right. The domain and range for both functions is all reals. All right. Now, in your Algebra 2 class, you may have applied the mechanical approach, which is fine. We'll do it along the way. All right. So again, let f of x be this rule over here. What do? We start by replacing f of x with what letter? Y. Replace f of x with y. All right. And then what was the key theme for inverse functions? We switch inputs and outputs. Switch x and y. So we now have x equals the cube root of y plus 5 all over 7. Now you solve for the new y. and think about the steps you apply. What do you do when you solve for y? What do you do with a 7? You multiply it on both sides. Then what do you do with a 5? You subtract it off of both sides. Sounds familiar? Then you do what? You take the cube of both sides. Sound familiar? That's what we did in the conceptual approach. Multiply by 7, subtract 5, cube the result. Multiply by 7, multiply by 7, subtract 5, cube the result. All right. Switch sides, y equals the cube of 7x minus 5. All right. And note that we're finding a rule for f inverse. F inverse of x is the cube of 7x minus 5. Same as what we got from before. All right. If necessary, impose restrictions to make sure these happen. Don't worry about that, but I'll discuss a temperature application in a moment.